Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of matrices and determinants. So if I talk about the question here, we have been told that x, y, z, let them be greater than 1. And we have been given a matrix A that is 1 log y to the base x, log z to the base x, log x to the base y. Then we have been given 2. Then we have been given log z to the base y. Then we have been given log x to the base z, log y to the base z, and 3. So this is the entire thing given to us. Now let's try to solve this further. So what we have been asked to find here is determinant of a joint of base square. So we need to figure out the value of this entire thing, and there are four options given to us. First is 6 raised to 4, second option 2 raised to 8, third option 4 raised to 8, and the last option given to us is 2 raised to 8. So let's figure out which one of the options is the correct answer for the question given to us. So before that, first let's find the determinant of this entire thing. So if I try to find the determinant of this entire thing, we are finding the determinant of 1 log y to the base x, log z to the base x, log x to the base y, 2. Here you get log z to the base y, log x to the base z, log y to the base z, and 3. So once I have 1, 2, and 3, if I try to solve this determinant as expanding it, we know 1 is 6 minus this, that is log y to the base x, log y to the base z into log z to the base y, minus log y to the base x. This we get that as log 3 times log x to the base y, minus here you get log z to the base y into log x to the base z, plus log z to the base x. You get that as log x to the base y into log y to the base z minus 2 times log x to the base z. Now once I expand this entire thing, easily solve this idea, we'll use the idea of change of base from logarithms. We know log a to the base b, I can write that as log a upon log. So if I just use that idea and expand my entire determinant which I had got here previously, I was having 1, 6 minus this. If I expand it, I get log y upon log z to log z upon log y. So you can just cancel it as it is. This gets cancelled with this and this gets cancelled. So you get here 1, so 6 minus 1, this becomes 5. Further, if I try to solve it, minus log y upon log x multiplied with. So I multiply log y to the base x with both of these terms. Let's see what I get. Log y upon log x multiplied with 3 log x upon log y. Minus of minus, that makes it plus log y upon log x multiplied with. This becomes log z upon log y and log x upon log z. Log z upon log y into log x upon log z. So if I solve this further, I get this understanding also. Log y gets cancelled, log x gets cancelled, so you're left with 1. Here, if you solve this, log y gets cancelled, log z gets cancelled, log x gets cancelled. So you again get 1. So minus 3 and plus 1. And further, if I see the last term which was there, log z upon log x If I see log z upon log x gets multiplied with this entire expression, so if I expand that as well, it is log x upon log y into log y upon log x. So you have that minus this becomes log z upon log x into 2 times this becomes log x upon log z. So if I try to cancel all the terms here, you get all of this cancelled, so you again are left with 1. Here also these terms are cancelled, so you are left with minus 2. So you get the value of entire determinant turning out to be 1 times 6 minus 1, so 1 times 5, that is 5, minus 3 plus 1 plus 1 minus 2. So you get the value of the entire determinant as 5 minus 5, 0 and plus 2. So you get the answer for the determinant of A opening out the middle. Now let's try to find whatever we have been asked for. We are asked to find the determinant of adjoint of A square. So if I use the idea, we already know determinant of adjoint of A, that's given by determinant of A raised to n minus 1, where n is number of rows or columns, or I should say n is nothing but the order of matrix. So that is 3 cross 3. So n in this case is 3 because you have 3 rows and 3 columns here. So if I solve this further, I get determinant of adjoint of A is this. So determinant of adjoint of A square, it becomes determinant of adjoint of A raised to n minus 1, that is 3 minus 1, that is 2. So square. And again we know determinant of adjoint, it should be A square. So determinant of adjoint of A square. So it basically again I can apply the idea here as this. So it again becomes this. So determinant of A square which is whole square, because again you are treating this A square as A here. So determinant of adjoint of A, you are applying the idea again. So you get this determinant turning out to become determinant of A square, the whole raised to 4. And determinant of A square we already know by the idea. I can write that also as determinant of A the whole square. So you get this entire thing becoming determinant of A square into 4. So determinant of A raised to 8 and determinant of A, we just figured out the value that comes out to be. So get the answer as 2 raised to 8 for the question which is asked to us to find the determinant of a joint of A square. So if you see the option that matches here with the question, it becomes option B. So B is the correct answer for the question given to us. I hope you have understood how to solve this type of questions. So first we figured out the value of the determinant using the change of base formula for logarithms. We figured out the determinant turning out to become 2. Once you figured that out, you just needed to apply the idea which was determinant of adjoint of A is determinant of A raised to n minus 1. That leads us to form determinant of A raised to 8 here for the determinant asked to us for the expression. That turns out to become 2 raised to 8, which matches with option B. I hope you have understood how to solve this type of questions. I'll also explain to you in this video how you can easily find the value of the determinant of A without actually solving this entire thing which we did. So let's see that shortcut method also to solve the questions. So if I see determinant of A, I needed to figure out. So the other method I can do here is find the determinant. One, I can write that as using the formula for logarithms, log x to the base x. Here I can write as it is, so log y to the base x and log z to the base x. Again, the next idea I had here was log x to the base y. So log x to the base y, and here we had log x to the base. So I wrote it as it is. Here I had 2, and since every column in the, every row in the second row has the same base y, so I'm writing that as log y to the base y, and this was log z. And here I have log y to the base z. Here it was 3, nothing was there means 1. So again I can write that in terms of base z as log z to the base. Now once you apply the change of base, you can write log x to the base x as log x upon log x, log y upon log x, and log z upon log x. So I understand 1 upon log x comes common from the first row. Again from the second row I can take out 1 upon log y common, and from the third row I can take out 1 upon log z. So what you get in the determinant left out here is log x, log y, log z. Second row you are left with log x, 2 log y, and log z. Third row you are left with log x, log y, and so what you are getting the answer here as is 1 upon log x, log y, log z. Determinant. Here if I see log x can be taken out common from the first column. From the second column I can take out log y common, and from the third column I can take out log x common. So if I take those out common, I get log x, log y, log z common. So you are left with 1, 1, 1, 1, 2, 1, and 1, 1. So you get this and this cancelled, and if you just figure out the determinant here, you get 1, 6 minus 1, minus 1, 3 minus 1, and plus 1, 1 minus 2. So you get 5 minus 1 into 2, so minus 2, that is 3, plus 1 minus 1, so minus 2. So you get the value of the determinant as 2 here. So if you understand how to find this method, how to use this method of finding the determinant, you can always use this method as it saves a lot of your time, that instead of writing all of these terms to figure out the value of the determinant, you can just use the idea and get the answer faster here. I hope you have understood how to solve this. Once you get the determinant value, you can just figure out the answer for the question asked as we did in the previous method. We get again the same answer as option B. I'll see you again tomorrow with some other question from some other topic. And we are going to continue our series of questions on 11, 12 as well as JEE mains. So stay tuned for more videos to roll out. Also, do like, share and subscribe to my channel. Do share these videos with your friends also who are involved in the preparation of questions on JEE mains. So they can also take the benefit from these questions which we are solving on a everyday basis. Thank you.